Buick Know-How has always been a solid resource for dealership technicians. We cover a wide variety of topics on anything that concerns Buicks. For example, drivability is just one aspect. Technicians receive better, more efficient methods to diagnose drivability concerns. How to improve mileage, how to take care of stalling and hesitation concerns, and reducing exhaust emissions. This keeps Buicks moving. Today, we're going to talk about the newest anti-lock brakes on certain Buicks. We're going to look at Delphi Chassis' Delco ABS6 system and check out the big picture too. Hi everyone, I'm Chuck McLennan for Buick Know-How. For the next 25 minutes or so, you'll be looking inside the Delco ABS6 system. The concerns you'll see will no doubt look familiar, but will shed new light on their repairs. The ABS6 system first appeared on the 1992 Skylark and Regal. The system was then added to the Century in 1994. With that said, let's dig in. The Delphi Chassis ABS6 hydraulic modulator assembly is bolted to the master cylinder. The modulator motor pack assembly includes two front and one rear ABS motor and a left and right front isolation solenoid. This system can only use the hydraulic pressure that is supplied by the driver's foot on the brake pedal. The hydraulic modulator unit houses three bidirectional motors and gear sets, a ball screw spindle, a ball screw nut, a piston, and a check valve. This motor and gear set rotates this ball screw spindle. The ball screw nut moves on the threads, moving the piston in the expansion chamber. Hydraulic pressure forces the piston down. During a normal stop, hydraulic fluid flows past the open check valve and front solenoid valves to operate the brakes. During an ABS stop, the front solenoid valves are energized to isolate the front brake circuits. Then, the motor of the affected channel is operated to move a piston down just enough to seat the check valve. With the circuit isolated, piston position now determines hydraulic pressure. As the piston is pushed up the bore, brake pressure increases. As hydraulic pressure pushes the piston down, brake pressure decreases. To hold brake pressure, the motor, gear set, spindle, ball screw nut, and piston must be stopped. Electromagnetic brakes and an expansion spring brake are used to stop motor rotation. The electromagnetic brake has a strong spring that clamps a clutch disc and shaft to the motor body. In an ABS stop, electromagnetic force overcomes the spring pressure, allowing motor rotation in either direction. If the EBCM commands a brake pressure hold, the electromagnet is switched off. The spring quickly clamps the disc to the motor body to stop the motor. The expansion spring brake uses a splined motor drive dog to turn a pinion drive dog. The pinion drive dog turns the motor shaft gear. The turned-in ends of the expansion spring are held between the two drive dogs. In an ABS stop, the motor and pinion drive dogs wind the spring tighter, decreasing its overall diameter in the bore. A small clearance is enough to allow the motor to turn. When the EBCM cuts power, the expansion spring forces the two drive dogs apart, allowing the spring diameter to increase and halt motor rotation. And that pretty much takes care of the hydraulics. Now let's talk about the EBCM. It uses information from the wheel speed sensors, the brake switch, and the ignition and battery inputs. On the 92 to 94 Regal, the EBCM is located between the left front fender and the left engine compartment bulkhead behind the wheelhouse. On the 95 and 96 Regal, the EBCM is under the left side of the instrument panel and under the right side of the instrument panel on the Century. The EBCM is located in the engine compartment bulkhead in the Skylark. The EBCM tests the ABS relay, the motor pack, the hydraulic modulator, and the front solenoids at each engine start. If the driver is not pressing the brake pedal when the engine is cranked and started, the EBCM tests the system right away. If the driver applies the brake when cranking and starting the engine, The system waits until the car is traveling at least 3 miles per hour before initializing. A buzzing sound may be heard as the modulator assembly is being tested. When the rear ball screws are moved, base braking is affected for 2 to 3 seconds. This is normal. See Section 4 of the Owner's Manual for a good way to explain this process to your customers. As the engine starts, the ABS warning light illuminates for a few seconds. Whenever the amber ABS light remains lit, ABS is disabled until the malfunction is repaired. The red brake warning indicator lights when the parking brake has been set, or when the brake fluid in the master cylinder reservoir is low. Consistent and reliable wheel speed information is the backbone of the system. The EBCM determines if a wheel is rolling, about to skid, or is skidding. The sensor generates AC current with a strength and frequency dependent on wheel speed. We'll be getting back to these sensors a little later in the program. For now, let's talk about how this system handles its diagnostics. Before I even start talking about anti-lock brakes, I must stress that an anti-lock brake diagnosis cannot be performed unless all 4 tires are properly inflated, in good condition, with acceptable tread depth, and that all 4 tires are the same size. Different size tires rotate at different speeds, causing the EBCM to set codes. The base brakes themselves must also be okay. Diagnostic trouble codes are stored in the EBCM as current and history codes, similar to the way the PCM stores codes. Diagnosing PCM concerns requires the technician to clear codes and reproduce the condition. The ABS6 system requires a different approach. The EBCM stores diagnostic codes like a PCM. However, clearing codes before the ABS diagnostic procedure is followed erases the possibility of a quick diagnosis. So, do not clear EBCM codes. The enhanced diagnostics can be accessed using the Tech 1. This provides a better overall view because codes are stored in the order that they occurred, as well as what the vehicle speed was and the number of ignition cycles since each code was set. This is very helpful to trace the degradation of a circuit. For complete system diagnostics, refer to the Know-How Manual and the steps in Section 5E2 of the Buick Service Manual. Now, I'd like to discuss several ABS6 concerns and repairs that the Delphi chassis division has developed. One thing I should mention is that the ABS6 has been a very reliable system. Delphi chassis is predominantly seeing wheel speed sensor concerns, which we'll address in this program. Now, on 1993 Skylarks, the ABS or brake warning light may come on prematurely. This concern is usually accompanied by codes 46 and 86. Code 46 detects a possible stuck expansion spring brake, a seized motor, or seized hydraulic modulator. Code 46 is always accompanied by a code 86. This means that there is a possibility that base brakes may be degraded. Therefore, the EBCM turns on the red brake light and sets a code 86. Perform a thorough diagnosis of the entire ABS system according to Section 5E2 of the Buick Service Manual. If other codes set in addition to codes 46 and 86, use the Service Manual to repair them first. Then, if these 2 codes are still present, reprogram the EBCM. Check the most recent upgrade to the mass storage cartridge. The September 1994 CD-ROM upgrade is the earliest version that can be used. The EBCM reprogramming function can be found on the Tech 1's main menu. Arrow down to reveal ABS6 reprogramming. Select the appropriate F key to begin. To program the EBCM, switch the ignition to run with the engine off and select ABS6 EBCM reprogramming. When you press Enter, you'll see Test in Progress on the screen. You're finished when you see EBCM successfully reprogrammed on the screen. Press the Exit key and then enter the chassis section and clear codes. With your foot off the brake, start the engine and allow it to run for 10 seconds. Shut the engine off and then restart it for another 10 seconds. If the codes recur, consult Section 5E2 of the Buick Service Manual for diagnosis. If the Tech 1 tells you that this vehicle has been previously reprogrammed and refer to Service Manual for further diagnosis, press the exit key. Now let's take a look at several ABS concerns. Codes 25, 26, 27, or 28 can set on these cars as current or history codes. These wheel speed sensor variation codes can be difficult to diagnose, so connect the Tech 1 and test drive the vehicle. Display the wheel speed data screen. Set the Tech 1 to the automatic trigger snapshot mode. After you drive the vehicle, take a look at the Tech 1 data. If the snapshot triggers, toggle through the data, looking for an erratic reading from one or more of the wheel speed sensors. For 1996 vehicles, when the EBCM was built before August 20th, 1995, the repair is to replace the EBCM. Check the date code. The 9th through 12th digits of the 16-digit serial number represents the Julian date. On to the next concern. This one is about 1991 to 1995 Skylarks. These cars can have a front wheel speed sensor that was not properly magnetized during the manufacturing process. Remove the sensor and try touching a steel wrench to the pole piece. You should feel magnetic pull. Then check the flat surface of the coil housing. If the build date is not stamped on the outer housing, replace the sensor. The next concern includes 1992 to 1996 Skylarks. These cars may set codes 21, 25, 32, 52, or 22, 26, 33, and 53. The codes may set individually, in any combination, as current or history codes. The sudden jarring of the suspension system can cause electrical intermittence that set codes. For 1992 to 1996 Skylarks, use jumper harness 121-40077 for the left and jumper harness 121-40078 for the right. If you just replace the EBCM, it's very unlikely you'll repair this concern. Now we'll move on to the Century. The rear wheel speed sensor jumper harness connector on a Century is located in the rear wheelhouse splash area. The connector is subjected to water throw-off from the rear tires, which could cause codes 27, 28, 34, 35, 23, or 24 to set. If the wiring is too tight, the weather pack seal can pull away from the inside of the connector. If this happens, the seal allows the water into the connector. If water is in the connector, moisture can wick up the wiring. The best repair is to replace the harness. Install 2 crimp and seal splices here. Refer to Service Bulletin 535013. The next concern covers wheel speed sensor connectors on a small number of 1995 Skylarks. These cars were manufactured with electrical tape wrapped around the connector to help support the wiring. Unfortunately, the tape causes the wires to flex and break at the terminal connection. When you inspect this connector, the wiring relaxes and contacts the back of the terminal, so the problem is usually not found, making the source of this concern difficult to locate. When testing the circuit with a meter, jiggle the wires at the rear of the connector to detect any looseness that could set codes. Replace the harness. The wheel speed sensor ring is made of a hardened powdered metal casting. An imperfection can cause problems when the wheel speed sensor ring is pressed onto the outer CV joint race. If the wheel speed sensor ring is pressed incorrectly, the ring can crack during the press operation. In operation, the EBCM is looking for 47 impulses per wheel revolution, created by 47 perfectly spaced teeth on the wheel speed sensor ring. If the wheel speed sensor ring is cracked, the controller could see extra pulses. The controller sets codes 25 and 26 and disables the system. A good visual inspection before any diagnosis could spot this concern. Even 1 or 2 chipped teeth on the ring can cause the same result. If the wheel speed sensor ring cracks, it can actually spin freely on the CV joint race. Now, let's move back over to the hoist area and look into a concern involving wheel speed sensor wiring on a Regal. Loose inner fender rosebuds on the Regal can cause the wheel speed sensor wiring to fall out of position and then rub on the brake pipe and fitting area. This results in a loss of signal from the wheel speed sensor. On some cars, the wheel speed sensor wiring can become so loose that it rubs against the CV joint boot. In extreme cases, the wiring can wear through the CV joint boot, causing CV joint failure. Anytime you diagnose an anti-lock brake system, check the car carefully for aftermarket equipment. Some aftermarket installers are not very careful. Mounting screws are driven into the body sheet metal and through wheel speed sensor wiring harnesses. Some installers think this wiring is a power source. Others think it's a ground for their device. Wheel speed sensor circuits are very sensitive. Any disruption of the intended signal causes the EBCM to set wheel speed sensor codes. Similarly, if a spark plug wire and a wheel speed sensor wire are routed too close together, secondary ignition voltage can induce huge spikes in the wheel speed sensor circuit. When wheel speed information is displayed if the car is not moving, you know that the circuit is being affected by induced voltage. A voltage leak is not exactly a short, but it is a loss of current. Most multimeters aren't sensitive enough to detect these leaks. The J39200 fluke meter can find leaks if it's manually set to the megohm scale. Now if the meter detects any reading, there is a leak in that circuit. If you do find a leak in a harness, replace it. Do not repair or solder in sections of wiring. These types of repairs break after a short time. The customer will be back with the same problem. Save yourself and your customers the aggravation. Replace the harness. Between May 1993 and February 1995, Delphi chassis changed the hydraulic modulator due to an initialization delay. In these cars, the motors in the hydraulic modulator are commanded to run to the full down position and back to the full up position during initialization. When the motors run to the full down position, the ball screw bottoms out and occasionally sticks. The EBCM sees the delay, disables the system, and sets a code. During the next several ignition cycles, the ball screw is positioned higher. After the 5th to 7th cycle, the proper position is attained. Then the codes stop setting, but are retained in history. Installing a new modulator repairs this concern. Codes 14, 36, 55, 58, 63, and 66 may set due to low system voltage. If the charging system allows battery voltage to drop near or below 9.6 volts, the EBCM disables ABS and sets these codes. The charging system must produce enough current to exceed demand. Starting an engine can cause a sharp current draw of over 200 amps. Then add the rear defroster, the radio, the climate control system, the headlights, and the wipers. The EBCM initializes as the engine starts. The electric motors in the hydraulic modulator motor pack themselves can draw up to 40 amps. This heavily overloaded electrical system severely taxes the battery and pushes the charging system to the limit. If the EBCM does not see at least 9.6 volts when it wants to start initializing, it will set low voltage codes and disable the system. Therefore, the battery must be fully charged with a green dot. Then, use a carbon pile charging system tester to load test the battery. Only a carbon pile can place the proper load on the battery. Ask the customer about other related complaints. Does the engine crank slowly? Are there components or other systems on the car that do not operate properly? If the MIL light is on, it could indicate an undercharging concern. If several complaints are related to a low power condition, that should indicate that the car's charging system requires attention. The most frequent and difficult to diagnose concern is a no data or no communication screen on the Tech 1 as the diagnostics are entered. That occurs when a loose ground or any power supply interruption prevents the EBCM from powering up. The next two concerns are about the motor pack. If you get a code 46, that means the rear motor isn't moving. In normal operation, the expansion spring brake stops the motor on EBCM command. The brake must release upon EBCM command as well. In high humidity, high temperature areas, the spring can stick to the motor bore. Some success has been noted if the motor pack is separated and then tested with the Tech 1. Run the motor test. If the motor pack runs, reinstall it. If not, replace it. Another motor pack test is to check its resistance. The motor pack should be 0 when checking between the motor and ground. There should be between 0.2 and 1.5 ohms across the motor terminals to indicate a good motor. Any reading over 1.5 ohms requires motor replacement. Now let's look to a rather interesting concern on the Century. This concern is very unusual. As the positive battery cable runs down from the battery and attaches to the starter solenoid, it can be misrouted too close to the transaxle mount. On some cars, when the engine torques over, the insulation is rubbed through by the transaxle mount. This could set codes 25 and 26. The transaxle mount is part of the cradle, which is insulated from the body by 4 mounts. A direct short to ground here does very little harm to the vehicle. It does, however, have an indirect effect on the wheel speed sensor circuits. Battery voltage can arc from a speed sensor tooth to the pole piece. This produces some extremely high indicated wheel speeds. Whenever inspecting the front wheel speed sensor areas, always check the battery cable in this area. Well, that's about it for this Know-How program. We've covered new repairs to concerns that were not previously addressed. And as always, be sure to look in your Know-How reference manual for all of the details. See you next time.